Ladies and gentlemen, we are going to be graphing systems of inequalities. This is going to be a piggyback on something that you've learned before in Algebra 1 this year about how to graph inequality graphs, along with something that you learned in middle school when you graphed two lines on the exact same line. Let's recall. In middle school, your teachers talked to you about how when you graph two lines on the same graph, the thing you were looking for was where the two lines intersected, because there is where your solution was found. Where we're going to apply the same understanding, however, now we will have shaded areas. So if I took this line here and made it a less than symbol for the orange, less than or equal to, that would mean I would then shade everything below in this graph. As you see, part of the blue line is contained in my shaded region. If I apply the same understanding to the blue graph and now made it greater than or equal to, what that means is that everything above the blue line is what I would shade. You will notice that there is an area that has two different colors for shading. Well, just like in systems of linear equations, two lines that were graphed where we looked for the one spot where they intersected, today our focus is going to be where the two shaded areas intersect. In this area is where I'm going to find my solution. The key is to remember I must be sitting in the double shaded area. Let's apply that today. So looking at your paper, we're going to do example 1 together. The yellow I find is a little difficult to see under the document camera. So for today, while you will be using yellow, I am going to use orange because it'll be a little easier for you to see. So let's start with our first equation. I'm going to graph this one right here. And when I graph, remember, I start with my y-intercept. I plot it first on the y-axis. I then apply my slope. My slope for this line, my m value, is 1. Remember, my slope moves in two distinct movements. Positive means to go up, and positive at the bottom means to move right. I'm going to apply this slope starting at my y-intercept. That means I will move from the number 2, up 1, right 1, up 1, right 1. I will continue with this pattern until I have completed my line in this direction. Now that I have half of my line graphed, I must complete the other half. I will now reverse these directions. From my y-intercept, if I reverse, that means instead of going up 1, I will now go down 1. Instead of going right 1, I will now go to the left 1. And I will continue with this same pattern until my graph is done. Now let's take a look at our inequality sign. My inequality sign is the less than sign. There is no line underneath, so that tells me I will have a dotted line. And because it's less than, I will shade below. Let's do that. Now, I will not connect my dots because it's a dotted line. I will leave them as they are. But I will shade everything below that line. That is my first graph. I will now graph the second one in blue. To graph the second one in blue, I will again start at my y-intercept, which is now at -3, and then I will apply my slope, which is a -1/2. When I apply a slope of negative, the top number tells me now to go down. However, the bottom number still tells me to go right. From my y-intercept of -3, I will go down 1 and right 2. 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 I will now reverse those directions. So instead of starting, when I start at my y-intercept, instead of going down, I will now go up 1 and left 2. 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 You will notice my line is now going in a negative direction. I now need to look at my inequality sign. According to this sign, will I have a dotted or a solid line? The answer is solid. I have a solid line because there is an equal to sign underneath. So I will connect my dots. I will now look at the symbol. Because I am pointed to the right, that tells me I will now shade above. So everything above this line is a solution to the blue graph. However, you will notice that there is a double shaded area right here. In this double shaded area is where my solutions will be found. Any point that is in this double shaded area or on my solid line is a solution. So let's find some points that are solutions. I will put good points in green and bad points in red. Because I am on this line, this solid blue line that is in the orange shaded area, it is a solution. So 4, -5 is a solution. Because I am inside the double shaded area, the point 6, 0 is a solution. However, because I am on a dotted line that is in the blue shaded area, it is not a solution because it sits on a dotted line. So the point 5, 7 is not a solution. So again, the red are not solutions, the green are solutions, okay? But I wanted you to see what makes something not a solution. If I am here in the blue, but not in the blue and orange, I am not a solution. So again, the point -4, 6 is not a solution. If I am down here in just the orange section, the point -3, -7 is not a solution. But if I'm in the double shaded, like the point 9, 3, I am a solution. The green are solutions, whereas the red are not solutions. Ladies and gentlemen, I would like you to try example 2 on your own and then come back to the video to check your work. Please pause it now. So let's check your work. Here's what your graph should look like. You will notice that when I graph the blue, everything above the line is shaded because it is pointing to the right. However, when I shaded the yellow, which appears orange on my paper, you will notice it shaded everything below, and it has a dotted line. There is a small section right here in the middle where there is double shading. I've highlighted it in yellow for you to see it clearly. Any point in this double shaded region or on this solid line is a solution. So when I tested the points by plotting them on the graph, you notice these two dots are only in the blue. they are not solutions. That is 2, 8 and 2, 3. Just like the point that's just in the orange section right here, -4, -8, they are not solutions. However, the point -2, -2, because it is on a solid line, it is a solution. The solid line is located in the shaded area, it is a solution. And the point 2, -9, because it is in the double shaded, it is also a solution. Please take time right now to complete example 3 on the back of your paper. When you look at example 3, remember you must first solve for y before you can graph. Please take a moment right now and solve both inequalities for y and then proceed to graph them on the graph. Come back to the video to check your work. Please pause it now. So let's check number 3. You will notice that in number 3, you only had to solve one of the inequalities for y. The first one was actually already solved for you, just not written in a form you may be comfortable with. I could rewrite it by just rearranging the information, but making sure that the symbol is still pointing towards the y. I could rewrite it as so. I can now graph this, and you will notice that both inequalities were solid lines because they both have an equal sign underneath. The first one will be shaded below, everything below the line. The second one is shaded above. But please notice that in this particular graph, there is no double shaded area. There is this blank area where there is no shading. In this case, there is no solution to this system. Very much like when you see two parallel lines, how there is no solution found. Because the two inequalities will never have a double shaded area, there is no solution. When I plotted each point, notice none of them sit in a double shaded area. This is a special case, ladies and gentlemen. Please take note of it. At this time, for the rest of class, your goal is to complete the exit ticket, which is found at the bottom of the video, at the bottom of your page, and then to start on tonight's homework. Thank you.